before we start with the presentation, Dr. Strongin and I are going to just do a few questions to help the audience get to know him. So welcome, Dr. Strongin. Great to have you.
Hey, thanks, Nigam. I really appreciate the invitation. Thank you so much.
Absolutely. So, yeah, so in this portion, we just like to ask a few questions to our guests so the audience can get to know them. So, Dr. Strongin, you and I met several years ago, and I think it was actually because I had read the paper referenced in your bio, that first paper you published in 2017, and we started corresponding via email. So it's interesting to me always when folks kind of transition from more traditional types of research into the cannabis space. So can you share a little bit about kind of what was your path or what was your inspiration to get into cannabis research?
Sure. A couple of reasons. You know, I think the research area and cannabis products have a lot of potential, you know, for medicinal purposes. But from a personal standpoint, we were studying vaping chemistry, and I came across a paper saying that a lot of young adults and teens were vaping cannabis, and we were set up to study this. One of the things that attracted me to the vaping field in general, that as sort of a concern, was the fact that so many young adults, middle and high school students were reporting e-cigarette use. And so that trend, you know, kind of continued with cannabis. And so we were set up to do vaping. It turns out that it wasn't so straightforward an adjustment because vaping cannabis products are a lot different than vaping tobacco products. But yeah, that's how we started. We started in the nicotine space and really saw that compared to the prevalence of vaping cannabis products, that there was very, very little being done from the basic research side. So we thought there was a big gap to fill there as well. And plus the chemistry looked really fascinating.
Totally. No, that all makes sense. And actually, as soon as I read your paper, and even to this day, when I'll hear people say things like, well, we don't really know what's happening in the vaping, or, oh, vaping's safe, I email them your papers. I really do. So I agree there's a big gap there, and it's just really appreciated that you and your group are working on that. So another question I had, and we were discussing this just prior to starting the session, is can you share a little bit about the areas of research you were in before and how that fundamentally links to what you're studying now in the cannabis field?
Sure. My training in grad school is in synthetic organic chemistry and also materials chemistry. So I already had been branching out and doing a lot of collaborative work just as a grad student, and really learned to appreciate different fields and really loved, you know, kind of working outside the comfort zone. It turned out that an accidental discovery by one of my students, I shouldn't say accidental because, you know, we all love serendipity, but not everybody recognizes it when it happens. He did, and that started me down in my independent career making biosensors, which was totally something I had no training on. We do a lot of fluorescence spectroscopy, but I myself have never used a fluorimeter. Actually, I shouldn't probably tell everybody that, but it's true. Anyway, the way we got into vaping chemistry was, and I had worked in pharma, but even before grad school, so I had some med chem background as well, but mostly synthesis type work, material synthesis, pharmaceutical synthesis, and then biosensor work was really an interesting new field for us. But one day, you know, after, you know, a decade or so, a decade or two in that area, one day, about 8 years ago or more, a couple of colleagues came to me and said, you know, you're our organic chemist. Can you tell us what these peaks are in this NMR spectrum? And I looked at it, I said, what you guys do? And it was actually an aerosol that they had collected from vaping an e-cigarette in the lab. I hadn't really heard about this. And I just kind of got pulled in because it turned out they discovered a new form of formaldehyde. And we've been collaborating. I started out collaborating with those guys ever since. And my group kind of branched out almost on our own, really, into the cannabis arena, whereas my original collaborators have stayed mostly in the tobacco e-cig field. I soon found out how hard it was to be able to work in this field, and so I know why now not that many people or not enough people are doing it.
Totally. And yeah, thank you for sharing all that. So this brings to mind several other questions, but I think it's more pertinent to wait till the end. So if it's okay with you, I'm going to stop sharing my screen, and can you go ahead and queue up your presentation?
Yep. Thank you, Negan.
Absolutely. All right, that's looking good. So it's all you, Dr. Strongin.
Great, thanks. So in the spirit of Journal Club, I wanted to tell you about a couple of really brand new papers, relatively brand new papers that caught my attention. It really helped me sort of introduce the significance of studying vaping chemistry and why we've kind of put up with the expense and going through a lot of sort of the legal hoops in order to do this. As I mentioned, one thing that got me interested in tobacco product vaping was a lot of the use by young adults. And because again, that chemistry, the younger you start inhaling air pollutants, for instance, the longer they build up, and especially in the tobacco field, things take a generation for the toxic effects to really manifest. So youth usage is something that we've always been concerned about by myself and my group, and it's very prevalent in both e-cigarettes, whether it's tobacco or cannabis usage, and still is, despite the EVALI outbreak. There is an overlap between nicotine and cannabis usage. I think a lot of it is because it's really hard to tell, when people have dual use, which is pretty common. It's pretty hard to, from a biological or biomedical standpoint, trace back the effects to one or the other, as we know from the EVALI outbreak and trying to pin down the causes of it. So speaking of which, there were, as of March this year, 2,800 hospitalizations and 68 deaths. We don't hear as much about it, and hopefully that's because things have been moderating, but I think a lot of the attention now is on a different concern, a global pandemic. And again, the outbreak was attributed to THC containing vapes, as we all know. But of course, many patients reported dual use again of nicotine and THC products. It's been really hard to pin down any kind of causative agent. And it's ironic, COVID-19 and EVALI have some very similar symptoms and manifestations, which I think is interesting. They both have deleterious effects, of course, on the respiratory system. And so, speaking of youth smoking and COVID-19, there's another the other paper recent paper that really caught my attention was this one from the researchers at Stanford that showed there was a 5 times more likely diagnosis in youth, in young people, of COVID-19 from cohorts that had used e-cigarettes. So that kind of caught my attention. It was a little bit higher in people that had done dual e-cig and tobacco, regular tobacco cigarette use, but just the fact that it was 5 times more likely from e-cigarette ever users of e-cigarettes was striking, but unfortunately not that surprising. So we still don't really know what caused EVALI. This is, again, from that first paper I introduced in Journal of Clinical Investigation. Laura Crotty-Alexander, someone I met once and a lot of respect for, and she's come up with some, interesting theories about the progression, the biology, how the cells are affected. And, similar to other researchers, the thought is that it's either a chemical burn or some sort of lipoid pneumonia or other type of manifestation. It's really unclear. I know at a meeting I was at with her and a bunch of other researchers, they were thinking it's more than one, possibly more than one disease. The cause is unknown, but what I want to do in the context of today's talk is tell you the bottom line is there's total agreement pretty much that EVALI is a chemically induced issue, a chemically induced lung injury. So again, that's adds more fuel to our interest, obviously, in studying vaping chemistry. It becomes, it became very, a very important area, more important than usual in the last year or so. And one chemical transformation, potential chemical transformation that's got a lot of attention has been the conversion of vitamin E acetate, which, as we know, is the main sort of suspect, I'd say, in if there is a causative agent or one causative agent of EVALI. And one theory is that based on a reaction, studied since 1938, where you have phenol acetates decomposing to ketene, that if you're forming ketene from during vaping vitamin E acetate, ketone's really toxic. It's about as toxic as phosgene. And so you can imagine, if you have sort of a dry hit or an overheated puff, you can get temperatures, definitely temperatures high enough to form ketene, and that's a pretty bad poison. And its etiology or manifestation takes some time, and it's kind of a little bit parallel to the time it takes for EVALI to really take hold and produce its most deadly symptoms. So it's really hard to study ketene because, as soon as it sees anything, it's going to react with it. So people, I've pointed out in my own papers that, biologists are going to have a hard time finding it because it's so reactive. It'll only be present as its protein adducts. So one of the questions is, was this outbreak, this vaping outbreak, just an outlier? Well, whether it is or not, one of the really, really surprising and concerning things about this was that, and we always, having worked in the tobacco vaping field for so long, we always go back to comparison to cigarettes. Cigarettes don't cause someone to, go to the hospital and die when they're really young, right? This is, to me, the most concerning and scariest and really different thing about the vaping illness that we've seen. We still don't know the long-term effects either, but it typically takes smoking-related disease to manifest over an entire lifetime, at least to even begin to manifest. So the rapidity of this onset due to vaping was really a huge concern in the biomedical community. But again, we don't know the potential long-term effects. So not showing these acute or immediate symptoms certainly shouldn't be taken as an indicator of total safety. And so there's a lot of attention turned to vitamin E acetate and cannabis product additives in general. And, the party line, the industry line, not so much cannabis, really the tobacco product party line, is that these materials we add, propylene, glycol, glycerol, they're all generally regarded as safe. They're used in cooking, et cetera, and so on. But, eating something is not the same as inhaling it. Right? So our stomachs and lungs are very different, which goes without saying. And the inhalation toxicology is not known for most of these products that we're inhaling. especially in the tobacco products and in many of the new cannabis products. No one really ever thought to study the inhalation toxicology of these products or these compounds, because nobody really imagined us breathing them purposely. So, you know, we have additives such as MCT oil, triethyl citrate, and still some propylene glycol. Are they safe to inhale? Well, we don't really know yet. We don't know the long-term effects. Certainly, most people don't have acute effects from these. But again, vitamin E acetate was justified as a cannabis product additive because it's a vitamin. So it's really hard to just tell what's going to have inhalation toxicity and what isn't. We do know from thousands of years of cannabis flower smoking that it's not going to cause a volley by itself, right? So it's definitely something that we've been adding to these products. There can be impurities like hydroquinones that are, you know, in vitamin E acetate that are really corrosive materials. And again, as I mentioned, the vitamin E acetate degradation might afford ketene, which is a highly toxic material to be inhaling. And again, there's no conclusive data. We're kind of doing a human stage 3 global human trial study, maybe unwittingly by most of us. And, you know, toxicity depends on exposure, but Aaron Botniger has taught us, at least in the tobacco control field, that heart disease and cancer are different in that with heart disease, even lower levels of intake can still cause heart disease as long as it's chronic usage over a prolonged period of time. So we think that cardiovascular health risk is actually more of an issue in vaping in general. We're not talking really just or exclusively about cannabis vaping, but vaping in general, mainly for tobacco products. So people say, oh, there's less of this and that than in cigarettes, but it might not matter. Even if there's half as much acrolein, et cetera, it can still cause heart disease because, again, those levels aren't as important as predictors. And also, again, the concern is the younger people start using the products, the more time you have to build up in your system. So the tobacco vaping industry really started using all these flavors that, again, were safe to eat. There's at least 8,000. The last count was several years ago. There were already 7,800 different e-liquid flavor formulations. So I would safely assume there's at least 8,000. I'm sure there's a lot more now as products keep coming on the market. And you know, again, one of the reasons, one of my motivations, and I again thank Nigan for asking, but another motivation aside from concern about young people, and I have my 6th, 7th, 8th, and 9th jobs are the fact that I have a 14-year-old adopted teenager right now. But so again, concerned about exposure to youth, but. Also, you know, after I looked at my colleagues' NMR, they were telling me that the industry, the e-cigarette tobacco industry, was saying that these products are made of water vapor. And I could see in the NMR, I didn't see hardly any water in that NMR at all. And the problem is they're still promoting some of these, I don't know what to call them. You can think of a term. E-cigarettes are as safe as drinking coffee. All they contain is water. These are relatively, I think, fairly recent, but really statements I don't agree with. I don't know how anyone would know this, even at this point in time. E-cigarette regulation on a pharmaceutical is like regulating coffee, right? And the lowest size particles are water vapor. I know for those of you interested in nanoparticles, find me a water nanoparticle, because I've never heard of that. Okay, so we know the lowest size particles are nanoparticles in the vapor, and if they're made of water, well, that in itself is is if they're made exclusively of water. That's really news, because I don't think that's possible. So the other main sort of argument for safety from, again, mainly the tobacco field, and we have a lot to learn from them in the cannabis field, is that users can self-regulate toxin intake when vaping. So toxins taste bad, right? Sure, but the problem is with addiction, especially with nicotine, we have receptors that start to inspired by the nicotine drive, kind of make the toxins more palatable. And, you know, I really hate to say that that kind of thinking is really wrong, to think that we can self-regulate toxin intake. That's one thing, unfortunately, tragically, that the Avali outbreak really showed was not true. Okay, and again, I've had personal correspondence from people around the globe writing to me and saying that, you know, they had no idea they were inhaling stuff from burned coils, and they couldn't tell the difference, just because they were too poor or whatever to replace their coils. So okay, so that's some background and significance, and really our inspiration and our passion for trying to study these materials, because, you know, they have so much promise to help people quit smoking traditional cigarettes. Who wouldn't love to see vaping, you know, replace that? But we still have to know what's safe or what can be improved about e-cigarettes. And in the cannabis space, there's so much you know, potential good, I think, as we saw in an upcoming talk, for, you know, maybe opioid surrogates and pain management. You know, I'm just fascinated by this, outside of my field, but we're looking for collaborators to help. And again, you know, but what my group is focused on, it's a little different than most other groups, is we're focusing not on the formulation ingredients, but really on the aerosol products. So what's in the aerosol, because that's what users are actually inhaling, right? And so that's what we've really focused our attention on, again, because there was a room in that space. And this is what we found and published many years ago. On the lower left is a review article, but actually this work was published a few years earlier by us. And propylene glycol, glycerol on the left, these are the degradation pathways, propylene glycol on the right. The main e-cig solvents, and I know some people use these in, you know, in cannabis products sometimes, or with other solvents, and basically they undergo dehydration and or oxidation reactions during vaping. And these are all the products that we found from vaping these materials, and again, at different levels, depending on you know, the usage pattern, the type of e-cigarette, et cetera, and so on. And so it's pretty complex, but relatively explainable chemistry that's really been known for like over 100 years. Maybe reported in the 1800s, definitely in 1900 or so by Neff, a very famous American organic chemist. So what about the additives? Well, the flavors, I mentioned how many flavorings there were added, you know, how many different formulations there are in e-cigs. And one thing that we've done is look at how flavorings induce toxin formation. And, you know, there is this paper by Klistov and coworkers that said that flavoring compounds dominate toxic aldehyde production during e-cigarette tobacco vaping. And this other group said, no, they don't do anything. The changes in toxin levels are statistically insignificant. So we took a common molecule, triacetin, that's not exactly itself a flavoring, but something that is a flavor. They call it a flavor enhancer. And you can see this is glycerol. It's really just glycerol triacetate. And at that time, a couple of years ago, even people were proposing this as a surrogate for using propylene glycol as a solvent. And we don't think that would have been a good idea. And what I can show you is clearly this overlay. The red NMR, so it's a proton NMR spectrum of an e-cigarette vaped with and without small levels of triacetone. And in the green in the background, you see the overlay of the spectrum from the triacetone containing aerosol versus, in red here in the front, it's the non-triacetone, just propylene glycol and glycerol vaped. And you can see the peaks are at least twice the size from, for acrolein, acetaldehyde, and for this form of formaldehyde that our group with our collaborators discovered, which is formaldehyde, but just having reacted with propylene glycol and glycerol. That's these big, tall triplet peaks here. So clearly, adding additives can add to toxic aldehyde formation. And we did carbon-13 labeling experiments and proved conclusively that these came from catalysis by triacetone, which produces acetic acid, which then catalyzed the acid catalyzed breakdown through those elimination or dehydration mechanisms that I showed in a previous page. So how did it become okay to add sort of food and vitamin additives to vaping products? Well, and again, it's started with the tobacco e-cig companies, but what about cannabis vaping formulations? A couple of relatively prevalent ones now that vitamin E acetate hopefully is not used anymore. But there's obviously, we have all heard about medium chain triglycerides. There's also triethyl citrate. There's a terpene, I think bisabol, not shown, and some other things. And again, we don't really know the inhalation toxicity of these compounds very well. Again, I haven't seen any reports about health effects on them, but I don't know that they have been investigated extensively as far as their inhalation toxicology. Interesting, triethyl citrate kind of reminds me of triacetone, except the oxygen positions are reversed. So we've also found, thanks to Vilpando and Associates consulting group, gave us a sample that they had dropped off at their offices in California that was, came in 2 vials. One was turned out to be pure vitamin E acetate, and the other one turned out to be something called pine rosin, which we had never heard of being vaped. And we looked on Reddit, because that's where we have to get a lot of our information these days, because of the lack of published literature, which we're trying to rectify ourselves. And this is what it looks like. This material, this is from a website, and it can be used in solder. It's used in solder, and actually vaping this is really bad because it is what causes the toxicity of solder fumes. And it's an industrial inhalation hazard. And the fact that people are using this as a cutting agent, or at least in samples, a sample that we got was very scary. You could see that this actually looks like shatter, I guess. It's also sold as fake shatter over the internet. And we found that at levels of just 1% in a THC oil, you have 3,500 times the 15-minute time-weighted exposure tox threshold. Now, what we got doesn't look like what you see on the left, doesn't have that structure. It actually looks like what's in the syringe. And so what else is in there to dilute it to make it look like a normal, I guess, oil product, THC oil product, is MCT oil. So that makes it fluid. We also found some other interesting ingredients, which all of these are just the common pine rosin constituents you'd find. But oleamide is interesting because that's something that people put in spice products. It's a hypnotic. So we were a little surprised, but then not so surprised to find that in this cutting agent used for cannabis product. And we just ordered pine rosin from Amazon, took an NMR. You could see it on the bottom here in green, and you can see every peak in the commercial pine rosin is that's in the green spectrum, is in the red spectrum, overlays almost perfectly. These two peaks here on the right are from the MCT oil. So we were concerned, about cutting agents still, and we're still on the lookout for others. And really, we reported to the Reddit people what that was, and the Redditors, I guess. And we haven't seen much of it since, and hopefully we don't see that people vaping that stuff anymore. So it was still, again, concerned about the trying out of other cutting agents. If anyone has samples they'd like to test, please send them. So let's talk about the chemistry of cannabinoids and terpenes when vaping, and that's something that we're obviously interested in very much. And what's been known is sort of how CBD A and THCA, et cetera, decarboxylate to form CBD, THC, et cetera, and so on, and how we get isomerizations and or oxidations to CBN, delta H, THC, et cetera, and so on. So that chemistry is pretty well known. And we went back into the literature because we're seeing a lot of products during vaping. And boy, we had to go back to the mid-1970s to really find any extensive work on heating and pyrolysis, if you will, of cannabinoids. And this work was done at the University of Utrecht. And of course, then we realized the reason there wasn't any work was probably because it's so hard to do this kind of work legally in the United States and a lot of other places. But these researchers were really looking for the effect of nicotine and acid on isomerization reactions that we saw in the previous slide, and they found many breakdown products. You can see that come from THC, a common one here in the upper left, where these are alcohols, and long chain R2 is olivetol. You can see these are just substructures of cannabinoids that they found, which isn't surprising. But again, that was back in the 70s, and that's all we had to go on. And then, there are these new routes of administration, like dabbing, and dabbing rigs can have all these different accessories, nail materials, which all might affect reactions that occur during vaping. And so we set up in the lab something where, we had an e-nail, so it could control the temperature. This is a Cambridge filter pad to collect particulate matter. And what we started to study was the volatiles, the VOCs that are formed, because that's where most of the air pollutant and well-known toxicants are going to be. And so we collect those on this ATD cartridge. But it's really hard with dabbing because you need such a large volume, and the ATD cartridge could very easily get overwhelmed by the amount of material, so we had to have a flow meter. Usually we use smoking machines. We can't do that with dabbing. We can with vape pens, but not with dabbing. So it's a lot more challenging to study. And for analysis, we use a variety of techniques depending on what we're looking for. And we do rely a lot on NMR because it's so non-destructive compared to a lot of the other techniques, and we use that for validation and also to find the less stable products. But that ATD cartridge that I showed here in the middle of this line, it's very easy to work with. You just take it out and put it in the mass spectrometer, and the materials get dissolved off, and we can find out what they are. And what we found from the terpenes, we found isoprene, and we've also found compounds that are very commonly found in the atmospheric degradation of terpenes. So methyl vinyl ketone and other, some aromatics, butadiene, et cetera, and so on. And the oxidation of a lot of these, oxidation of isoprene, for instance, is known and forms a lot of the same products we're seeing, although we do know that some of these do not form exclusively through isoprene. We now have found some other pathways using some isotopic labeling to follow the origin of these materials. So what about the THC dabbing again and vaping? Again, the chemistry work on this pretty much outside of the mass spectrometer pretty much stopped, you know, as far as heating and smoking or vaping these materials due to legal restrictions. And what we found, and it was a little surprising, that in the gas phase, and not the particle phase, of the gas phase, the products were the same as what we saw pretty much from the terpenes. There were just less of them because the cannabinoids they have rings, I guess. They're just more stable. They're harder to break apart. But we saw the same product distribution, just different levels. When you think about it, it makes perfect sense because cannabinoids are simply terpenophenols. They're also terpenoids. So getting the same sort of product distribution that we got from myrcene and other mixtures of terpenes really wasn't surprising. But, you know, from the old days when, you know, we know the contents of marijuana cigarette smoke, but we don't really know what comes from what. And so being able to do control experiments like this, we can tell what components are causing which breakdown products, which is quite helpful, I think. So, you know, there's a lot of products. This is just a chromatogram. You can see them, but let me, this is from just dabbing THC, pure THC. And again, we see a lot of the same products from dabbing pure terpenes and from mixtures. And here are the sort of the well-known HPHCs. Those are basically air pollutant molecules, or molecules known that also are seen in cigarette smoke. And so from dabbing pure THC, here are the levels. SID is a synthetic distillate. And I want to tell you what we use for these experiments are 9-to-1 mixtures of THC and terpenes. And that's important. That actually is fairly close to a lot of distillates that are available to the public, but in concentrates, you know, where you have distill the initial extracts and then add in terpene formulations. And so that's what we would do. We'd just take pure THC and add in 10% terpenes. And we found that from a viscosity standpoint, that was best for vape pens. It wasn't too viscous. You know, THC is, you know, and CBD even worse, like a solid. And it's really hard to even weigh out. And having, if you use pure terpenes in the vape pens, sometimes they just fall right through because they're so fluid. So we found 9-to-1 was perfect, and as probably no coincidence that is reflective of a lot of commercial formulations as well. So our synthetic distillates, where we use both, are here. And you can see that going from pure THC to adding terpenes, the levels of these compounds does increase. And not surprisingly, vaping, we get lower levels, typically a lot lower levels than dabbing. And the lower the vaping wattage, we've got it in volts here, but same thing, analogous. The lower the wattage, the lower the power, the less of these products you get, which again is totally expected. And what we did, and we've gotten, I can't tell you how much flack we've gotten for this, just even in the last couple of weeks. My student, some of you know, Jarius, went through all the cannabis literature and found out, was able to do sort of a hazard index calculation, which is non-cancer health effects, mostly CVD type things, and then lifetime cancer risk calculation, and got these just extrapolating from the literature. These hadn't been done as far as we could tell for smoking non-tobacco marijuana cigarettes. And we found that, you know, dabbing is less toxic than smoking, as far as, you know, we're producing less toxins, and that is, and what these do is they're not, these are sort of the effects of all those toxins on the last page combined, right? And some have a greater contribution than others, et cetera, and so on. And that's basically all these calculations tell us. Gives us an overall picture. But I have to say that this is isolated. This is just based on, you know, 7 or 8 toxins or compounds that we're seeing. It doesn't take into account the particulate matter, which we're studying now, and a lot of other things. So I have had people say, you're saying that, you know, vaping is totally safe compared. Well, you know, I'm not saying that. It's safer in some respects, for sure, which is good news. You know, that the toxicants, these HPHCs, are present at lower risk levels overall, and they really are. I wouldn't take these numbers at face value. It's the trend that's important. And you could see these trend down with lower power, and they definitely trend down from smoking to dabbing to vaping. And again, we totally expected that. So that's kind of an overview of what we're doing. We, you know, just to summarize, you know, vaping chemistry, our study, we're very passionate about how it can inform potential health effects. Because, you know, Avali, again, was an exception, but it usually takes at least a generation to get the type of epidemiological data you need on these types of products, from what we've learned from tobacco control. So in the meantime, just understanding what toxins and byproducts might be in an aerosol, I think, is the best we can do for now. And, you know, we're studying sort of the efficiency of aerosolization, that is the transfer efficiency of THC and of CBD, just, you know, so medical professionals can know what the dosage they're giving to their patients, right? And that's going to be based on route of administration, formulation, et cetera, and so on. And, you know, the target keeps moving as new products come out, but we embrace that because it gives us fresh new work to do. There's a rich chemistry of cannabinoids and terpenes that are understudied, again, due to the rules and regulations that have been around for too long, but we're trying to fill that gap. And right now we're studying the particle phase properties and composition, as I mentioned. Again, we've just focused on the gas phase till now. The chemistry of any additives, especially new ones. We're also looking at MCT oil and some other products. And we're always on the lookout for new vaping trends and new formulations. And with that, I'd like to thank Jarius, who's done all the work I talked about today on the cannabis studies. Nicole, who's a brand new student, who I actually met at the ACS CAN meeting, I think in Orlando, and she's now my grad student. So yeah, a wonderful byproduct from our participation in the meeting. It's just great to have a grad student be interested in joining our group from coming to the CAN meeting. And Alicia, who's been a terrific undergrad, working side by side with Jarius all these years. And I have funding currently from NIH and FDA, US FDA, mainly for our nicotine work. I did let them know when the Valley broke out, you know, that, hey, we better, you know, you guys better let us look at cannabis vaping, and none of this is their responsibility. This is all my fault. Don't blame the NIH or FDA for anything that seemed like an opinion or a finding, et cetera, and so on. I take full responsibility. And with that, I'll turn it back to Nigam. Thank you so much for listening to me and giving me the privilege of sharing our work with you.
Well, thank you, Dr. Strongin. Really, really interesting stuff. So we do have several questions from the audience. So I'll start with one. One of our attendees is asking if capital no, additives were used in making cannabis concentrates for vapes and extracts was 100% cannabis derived. Do you think it could be considered harm reduction as compared to smoking cannabis? Not, quote, safe, but, quote, safer than. Seems that Avali mostly points back to additives and illegal market practices.
That's right. I mean, we don't have a lot of data on smoking, vaping concentrates or inhaling the concentrate materials, but the ingredients in there have been used for a few thousand years. So you would think, again, it's not, we can't see absolutely because it's a different route of administration. But you would think that there's less heat. There are compounds that have been being inhaled for a really long time, and you would think it would be safer that way without the additives. Yes, but we don't really know. I can't say for sure. I haven't done the study or seen any studies about it, but that's what, I don't want to say common sense, but yeah, that seems to be what it looks like as of right now. But I wouldn't commit to that until that was studied. But yeah, because, you know, vaping can do different things to our lungs than smoking. So far, it seems overall not as bad, but we don't really know.
Just
great question.
Yeah, I agree. And quick kind of counterpoint or follow up from me is, what is your opinion of some of these products on the market? I see that when you were doing your experiments, you had the 9-to-1 ratio THC to terpenes. So my direct question is related to the last topic. Even if it's cannabis-derived terpenes, if you're putting such a large amount in, for example, a vape cartridge or a sauce, do you think that has any implication on the byproducts that come out the other end?
Yeah, thanks for asking. So one of our main general findings is that, at least for those HPHCs, you know, the known air pollutant type compounds, the cigarette-derived byproduct type compounds, that more of those come from terpenes than from the cannabinoids. So you may be exponentially increasing those. So I've discussed this with some of you I know in the audience, and you know, 30% terpenes. Wow, that would be kind of overboard, in my humble opinion. You'd be creating a lot more of those byproducts than you really need to. I don't really know why, you know, we should do that. I would recommend from what I know, I would recommend against it. Again, you know, we're at the beginning of this. So.
Totally, yeah, and I won't push the point, but I just kind of wanted to put that out there. So, okay, so on to our next question. What are some specific screening methods for evaluating the inhalation toxicology of substances, and how can we begin to report that data in terms of risk relative to smoked or vaped cannabis and cannabis-derived products?
Yeah, great question. I'm a simpler organic chemist, and I haven't stepped out yet into studying cells or animals, but I do have collaborators, and you know, you would expose lung cells, for instance, to the aerosol, just like you would expose to a cannabis aerosol, just like people have been doing with e-cigarette and also tobacco cigarette aerosols. And you start there, and then you work to small animals, to mice. And we have friends and collaborators actually doing that sort of thing right now. So there are setups, experimental setups to do that for e-cig aerosols. With both, you know, and from the tobacco control field, definitely with regular cigarettes. And you would go through those stages. You'd go through those steps, starting out with cytotoxicity on healthy and on lung cells, and even on maybe damaged lung cells, because you have people maybe that are quitting smoking using both of these products, et cetera, and so on. And so, yeah, we're working with collaborators exactly on that right now to really see what, you know, the effects are and to show relative toxicology. But it's so hard because, you know, it's just difficult with government regulations the way they are. We have DEA approval, and I may have some of you in the audience that know us. What we had to do, we got a DEA license, but until we get a NIDA approval to use their products, we've been using analytical standards of THC and vaping that. which is prohibitively expensive. But we thought it's important enough to do that. So think about if you're a synthetic chemist, instead of using starting materials, you're using analytical standards, and how expensive that would be to, you know, to do experiments with. So that's what we've done so far. So yeah, there's just such, we're so far behind. If you think of the prevalence and the popularity and the legalization now, the science is just so far behind. And I know all of us are interested in harm reduction and using these products for good. And you know, it's just hard to get these answers under the current conditions.
Yeah, I appreciate that response, and actually, I'm tempted to jump down a whole rabbit hole with you on that topic, but we have some more audience questions and just a little bit of time left, so I'm gonna move on, and maybe later we can host a can session or something on that topic. But here's another question from the audience. Do you have thoughts on surrogate methods for evaluating degradants from these ingredients in vaping formulations, such as thermal desorption, GCMS, or headspace, SPME, evaluation of neat ingredients?
Yeah, absolutely. They're all fine. They're all fine methods for this. You know, as long as I realize that you're going to miss certain products with certain techniques, and you know that certain techniques are better for certain products than others, or ingredients than others. Sure. Yeah, some things may need derivatization for GC, others may not, and so one's got to really be aware of the molecular properties that one's analyzing to use to match the technique. But yeah, those are all great techniques. They're all used. All of those are used on tobacco, the tobacco e-cig world. So I don't see why not. For sure, great.
Got it. And just for audience members, I see some questions that are more biologically focused. As Dr. Strongin has mentioned that that's not his area of research, I'm going to go ahead and move past those, but we do appreciate you asking these thoughtful questions. So here's another question from the audience where they're asking, there is some evidence that phytol, which is added to some vape liquid, can be toxic to the respiratory tract. Have you done any work on analyzing phytol thermal breakdown products?
That's something we're working on now, but I don't have results yet. Phytol looks fairly stable, but we'll see.
Okay. And here's one that I think this is really pertinent, and it comes back to what you were speaking to before. So, question from the audience is, realistically, how much weight should we put behind this toxicity of terpenes / cannabinoid byproducts issue? Is it an immunocompromised person issue, or maybe all people should be cognizant? And have we at least done a general screen on current products on the market dependent on molecules and functional groups?
Yeah, thanks. We're not allowed to use, well, we're allowed to use products on the current market for our own personal use, but ironically, we're not allowed to go to the dispensary and do research on those kind of commercial products. Yeah, it's, you know, the work's in its early stages. I just, you know, it's a hard question to answer. You know, when people see the data we have on the gas phase products, it does look like they're pretty benign. I had someone at a regulatory agency a week or two ago say about our paper, and they knew I was in the audience. They said it. And you found that there were no health effects associated with these, you know, based on that the hazard index data we showed. But, you know, it's only part of the story so far. That's all I can say. That's what we know so far.
Yeah, thanks for that response. So when we're really close to out of time, I just want to ask a couple kind of closing questions that plug in directly with what you were just saying. So, and this is a question that I had myself, is that as you mentioned, you're working with regulators, you're working with federal agencies, you're working with all these people. So my question is, are these folks who are not scientists, are they understanding the chemical evidence that you are generating? And what are the major challenges you face in communicating the meaning behind that?
Most of them, the ones that work directly with me, so the people certainly at the NIH and the FDA definitely understand what we're doing, and if not, we talk about it, and they're very, they're very interested. They're mostly people at that level. They're mostly biomedical people and biologists. So that's really not that big a cultural gap. But others, yeah, we have to present the work in a way that at least can allow people to understand the bottom line, or the helicopter level, I think it's called, of what we're doing. And so, yeah, and I can say that on a one-to-one level, the people want, they really all want the regulations to be relaxed for researchers. It's not so much the regulators as far as research goes that are stopping the progress. It's the politicians. So if we want to change that, we need to talk to the politicians. In fact, the federal the people in these agencies, they're not allowed to lobby, or they're not allowed to do that. They want to, but they can't. They're not allowed, but we can. So yeah,
I see. And so then
feel free to reach out. They listen to the ACS. ACS is a pretty big voting bloc, right? It's the biggest society in the world, right? Biggest profession.
No, and we take a lot of pride in in bringing these very pertinent cannabis topics to the fore, and we've had a lot of success recently in growing our programming at ACS meetings, our membership. So, I appreciate you bringing that up, and we'll keep that in mind. So, last question I want to ask you, I think it's a nice closer, is what comes next? So you can answer that however you want. Maybe it's what comes next for your research, maybe what you think comes next for industry regulations, kind of whatever thoughts you want to leave the audience with.
Thanks. I've been shocked how fast this field has evolved and all the stuff that's happened. And if you think about it, with Avali and the COVID has kind of pushed it into the background a bit, but there is, there is some cause for concern there of vaping and COVID. But as far as the field, it's so unpredictable. It depends on what kind of again, administrations we have, and just how the state and federal regulations get reconciled to make the work more doable, so that we really can help people better and make our for those of you in industry, make our customers better informed and better able, make us better able to help them. But I don't know. I mean, I've stopped trying to make predictions. Avali was a shocker. I was shocked to see people saying that tobacco e-cigarettes are made out of water vapor and nothing else, and water and nicotine. I mean, I've just been surprised. There's bombshells. Like every year there's something new that just surprises me. So I've stopped predicting. I've tried to, instead of being a forecaster, to be an adjuster and somebody who's vigilant. So I hope that's not a cop-out answer, but that's the best I can do.
No, I think that's an extremely reasonable answer.
I'm hopeful we do. I'm hopeful that the medical breakthroughs come with cannabis, and that we can use it, for a lot of benefit to society, especially for people suffering in pain. That's my hope.
No, I think that's actually a nice closer. So anyways, Dr. Strongin, thank you again for joining us and for your excellent presentation. Thank you to all the audience members. Be sure to tune in next month for September's edition of Can Journal Club, and we'll see you all then.
Thanks, Digga. Thanks, everyone.
Yeah. Thanks, guys. Bye.